Assalamu alaikum. My name is Dr. Amr El-Dieb. I'm the chair of the Civil and Environmental Engineering Department. The civil engineering is one of the oldest engineering disciplines known by mankind. Civil engineering is always associated with civilization. You could see the impact of civil engineers daily in your day-to-day life activities such as houses, buildings, high-rise buildings, clean water, sanitary systems, roads, traffic systems, railways, and many, many others. The mission of the department is to serve the country and the public through providing the highest quality civil engineering education using innovative delivery and interactive methods. For more than 35 years, the Civil Engineering Department has prided itself in graduating competent civil engineers who have been successful in practicing civil engineering profession and who are accustomed to the highest international standards of engineering. The Civil Engineering Department has more than 20 highly dedicated full-time faculty members. All the faculty members have earned their PhD degrees in civil and environmental engineering from leading international academic institutions. The qualification of the faculty members reflect the diversity of experiences and academic backgrounds of the faculty in the department. The study in the civil engineering program covers several areas of specialization that includes structural engineering, concrete technology, surveying, highway and transportation engineering, geotechnical engineering, construction management, water resources, and environmental engineering. Also, the civil engineering department has several specialized laboratories with state-of-the-art equipment that serve both the educational and the research needs of the students and the faculty. The experimental work and physical models are regarded as an essential element in the educational and research process. The department continuously adds the latest and new equipment to help achieving the programs and objectives. I wish to see you all in our department and in our labs.
Structural engineering is a branch or discipline of the civil engineering, and it involves, as a structural engineer, it involves the design of structures, and these structures could include buildings that range from villas to high-rise buildings, bridges, highway bridges, rail bridges or pedestrian bridges. Structures could also involve water dams, tunnels, elevated water tanks, stadiums, oil platforms or gas platforms in the ocean. The role of you as a structural engineer is to make sure that your design will yield a structure that is able to resist the loads that the structure will be subjected to, and these loads could be environmental loads such as winds, earthquakes, or regular human usage. And also you need to make sure that while in service, these structures do not deform or twist or fail, and they are stable, strong, and safe during their lifetime.
Concrete is a composite material made of a binding agent, aggregates, water, and in some cases admixtures. Concrete can be used in different applications, including beams, slabs, columns, foundations, and even non-load-bearing elements such as concrete masonry units. Concrete technology is actually the study of the applications and the properties, the behavior, and even the mechanisms of concrete. The role of a civil engineer who specializes in concrete technology depends on his role, whether he's at the provider side or at the contractor side. If he's a provider of concrete, then his role is to get the material, assess, evaluate, even test, and make sure that whatever he's requesting from the contractor side, he can actually deliver in terms of workability and in terms of strength properties. On the contractor side, the civil engineer specialized in concrete technology, his role is actually to make sure that the material that is received on site is actually an appropriate material. It is designed exactly as they requested in terms of slump or workability and compressive strength. The challenges faced by a civil engineer in the area of concrete technology are so many. You have things that go from wrong mix design to wrong placement, wrong vibration, and so on. The problems even go deeper into deterioration, corrosion of steel, or even at some cases, we're talking about scaling or durability problems. Now, what an engineer can do to solve these problems is, one, make sure it doesn't happen from the beginning. So they need to make sure they have proper placement, proper mix design, proper casting, vibration, and so on. And if a problem does occur, there are mainly two ways to solve them. One, either by repairing the concrete, or in a more dramatic way, they would need to destroy it and recast it from the beginning.
قسم الهندسة المدنية في جامعة الإمارات. اليوم رايحين نحكي لكم عن كورس المساحة. تعرف المساحة بأنها هي عبارة عن فن وعلم وتكنولوجيا نستخدم هذه الثلاثة أفرع من أجل تحديد مواقع النقاط على سطح الأرض، وبالتالي إحنا بنوصف وبنقيس شكل الأرض لتطبيقات مختلفة. فعندنا ممكن إحنا لو في عندنا إشي نقاط موجودة وبدنا نعمل لها خريطة أو خارطة أو مابس، فإحنا بنستخدم أجهزة وتقنيات المساحة من أجل هذا العمل. لكن لو كانت في عندنا مخططات عملها المصمم بدنا ننفذها، بدنا نبني فيلا، بدنا نبني جامعة، بدنا نبني whatever، فإحنا بنروح نستخدم تقنيات المساحة من أجل إن نبني. فعندنا تطبيقين، يا إما إحنا بنسوي خارطة لإشي موجود، أو بنبني شيء غير موجود على المخططات. لدى جامعة الإمارات قسم الهندسة المدنية وبالذات مختبر المساحة أحدث أجهزة موجودة عالمياً علشان إحنا نستخدمها في عمليات المساحة. عندنا أجهزة مشان المناسيب نسميها إحنا جهاز الليفل، بندرب إحنا الطلبة عليه في كورس المساحة. في عندنا جهاز لقياس الزوايا اسمه الثيودولايت، وفي عندنا جهاز بقيس المسافات وبقيس الزوايا بنسميها التوتال ستيشن. في عندنا في مختبر المساحة عندنا سرب من الطائرات التي عملنا لها كاليبريشن أو معايرة بحيث تصير تنفع لعمليات المساحة الجوية. بالإضافة لذلك عندنا قريبا إن شاء الله راح يكون عندنا في تقنيات الليزر أو اللايدر اللي ممكن نسوي فيها مخططات ووصف للطبيعة اللي موجودة حوالينا. بالنهاية أحب أنا أتمنى لكم كل خير وكل توفيق، وأهلا وسهلا فيكم في قسم الهندسة المدنية. ولما تيجوا عندي في كورس المساحة رايحين نرحب فيكم ونعلمكم وندربكم إن شاء الله على أحسن وجه. بهم شد البعنات قاعدات بيجي علي.
My name is Sam Zainuddin. My area of specialty is construction engineering and management. Actually, this area of specialty focuses on how to manage construction projects. And as everybody knows, construction projects have different types of projects, like building projects, high-rise building projects, low-rise building projects, residential projects, office buildings, dams, highways, roads, all types of construction projects. Basically, how to manage these projects. And when we say how to manage these projects, we mean from three main aspects. How to manage the quality of the project, time or the schedule of the project, and budget or the money in general. And when we talk about these three main components of a project, we mean that we need to reach to a successful completion of the project so that the project finishes on time, within the budget that is required by the owner, and within the time frame that is set by the owner and the other stakeholders of any project. When we talk about projects, basically we say, okay, we manage these three components, but we also have to manage the resources, meaning we have to manage people, the equipment that we use in the project, the material, and of course we have to be able to manage the money that we have and the time that is assigned for any project. A successful project normally should basically be well managed. When we say well managed, it means again, we have to reach to a successful completion in terms of, again, money, time, and budget.
Assalamu alaikum. I'm Dr. Mohammed Hamouda, Associate Professor of Water and Environmental Engineering in the Department of Civil and Environmental Engineering. There is a capstone fourth-year course called Water Resources. In it, you will learn a lot about water resources engineering with respect to drinking water supply, wastewater collection systems, the impact of rain and hydrology on the urban environment. As civil engineers, we build the urban environment. We build cities, we build roads and airports and so on. The impact of rain on this built environment could be catastrophic because we can get rain of high intensity, and it did happen in several countries in the Middle East, and in the UAE we had several high event rains, and they caused flash floods that damaged the infrastructure. So as a civil engineer, it is our responsibility to learn how to quantify these events and to safeguard our built environment from the impact of these flash floods. We first quantify the rainfall event, and we design the urban drainage systems that control them. We also design the drinking water supply systems so that everybody can open a tap and find the water right there for them to drink. That's one of the main responsibilities of a civil engineer.
Environmental engineering is the utilization of basic science like biology, chemistry, math, geology, and with the engineering thoughts and practice to solve environmental problems. Now, these environmental problems could be related to water supply, waste management, or remediation of contaminated sites, could be related to the control of contamination into the air, into the soil, into the water. All these aspects are areas that environmental engineers get involved in. Now, the field of environmental engineering, actually, it's a new field. It's about 50 years old in terms of the naming. Before that, it used to be called in the United States as sanitary engineering. And the focus at that time was on water and wastewater treatment. And this is why it started with the civil engineering and continued with the civil engineering. But later, as it expanded to other areas, other departments start claiming to have environmental engineering, like mechanical engineering, architectural engineering, chemical engineering, because they have areas that are related to such field. And you even can see in the United States, some colleges of engineering, they have a standalone department that is called environmental engineering.
Geotechnical engineering is a branch of civil engineering. It is related to the study of the behavior of earth material, soils, rocks, under the change in loading. Change in loading here means loading, you add load, or unloading, you remove load. If you are constructing a building at a site, then you are adding load on the soil. So the behavior of the soil due to this loading is geotechnical engineering. On the other hand, suppose you are excavating the soil, then you are removing part of the soil. You are doing unloading. The study of the behavior of what happened to the soil here is geotechnical engineering. Soil properties are the basic elements that are needed for the design of any underground structure to determine the strength of the soil, to determine the deformability of the soil. Let's take and go back to our example. You are constructing a building at a site. So there are two issues here. You have to know whether your soil can carry this building or not. So you need to determine the strength of the soil. You need to know whether your soil is strong enough to carry this load or not. At the same time, the added load on the soil is going to pressurize the soil. The soil is going to deform, it's going to displace down. This is called settlement. When the soil settles down, what happens to the building? It's going also to settle down. So this settlement might cause the building to not functioning well. So it means it will lose the functionality of the building. The building itself might crack due to this settlement. So you need to judge that. You need to know the properties of the soil. You need to know the deformability of the soil.
Transportation engineering covers many aspects of the transport of people from one point to another. So these aspects are specialized or subdivided into planning, design, operation, and maintenance. So these cover different systems within the transportation system. So the different systems are highways, even local roads, bridges, airports, ports, seaports. These systems within the intermodal transportation system all require, number one, planning. So when we cover the supply and demand of people, so these projects mainly are concerned of a demand from the population within a city. So we talk about the demand, and then we talk about the supplies. Our job as engineers is for our system not to fail. Now, failure doesn't mean necessarily a structural fail. We're talking even about the congestion. So if we get continuous congestion on a certain route, this means that this system is nearing a point of failure or has failed. As you know, UAE University, and especially the Department of Civil Engineering, has an environmental component to it. So we need to always focus in all of our projects, we need to focus on the environment, just like we focus on the structures. As a student, when dealing or when studying transportation engineering, we're talking about alleviating congestion. So we're dealing with traffic. We're dealing with the intermodal system, like I said, with transporting people from point to point in buses, in railway, even in waterways. We're also dealing with the design of the pavement. So the design of pavement has two parts. We talk about the geometric. So this is our job as engineers to deal with that. We also deal with the structural design of the pavement. So our job is to build a resilient pavement, which is economical, which requires less periodical maintenance, and that can last the design life.